Okay, so TensorFlow developer certificate and my computer vision domain status. So this is the book Zero to Mastery TensorFlow for Deep Learning. Very hands-on, some concepts. If you want to learn quickly, I would recommend Kaggle Learn. Those two courses are very good. But otherwise, these two are quite good for the certificate prep. So here, the first were fundamentals done for transfer learning and convolutional neural network was the journey. That journey, I think I've mentioned this before. It was quite difficult to get up these libraries, get to work. Okay, it's things are always in motion and changing, and the libraries, especially TensorFlow and Keras, they have a very chaotic history. Whereas in PyTorch, it follows a different philosophy. PyTorch follows a philosophy of Einstein, wherein it has not changed its API from version to 2 point version right now. It gives small minimal number of features, and that's why it is easier to maintain it. Whereas TensorFlow, in attempting to give fancy features, they kind of like they are not yet able to build full coherent feature set. So if you want to just get second example and you want to just visualize, if it is depending on what kind of thing it is, it will give you an error. So there are so many minor things. So in kind of like philosophy, this was the annoying thing to work. Even in my local installation, it was annoying. But what can I do? Eventually I moved to Colab, and this is what it is. So things here were this. It is time consuming to download data set. Okay, here if you check in the code, okay, this is pretty fine because I had to move to Colab. Every time you start something, it's a new session. Storage, which is mounted here, gets deleted. So I need to download the data set every time. It is very time consuming, not very, to be really honest. This is around 4 GB. Okay, so 4 GB of data. If I kind of like this here, it on 10 Mbps, or maybe our current net speed is around 4G, 80 Mbps. So around 7 to 8 minutes, and then processing time is similarly that much. So it every time it is you need to wait. You can't start executing immediately. If I wanted to show demo, it would take time because I had downloaded it before. This was quicker. So this is the code for it. So these were the annoying things, but the important is what was discovered during the process. So first thing is simplify code. There is something called as glue code or boilerplate code. Okay, if you check what is its definition, boilerplate code, it is like a code which is just it's a lot of lines you need to write just to get tiny thing working, and it needs to be repeated again and again and again in multiple places, so there is not much change. So what it does is it makes code ugly to read. You can't easily understand where the change is. It's just fucking hell. Okay, so whenever learning, I try to go and simplify, reduce the number of lines so that it is extremely easy to read and understand. I have made the code of this transfer learning thing into simplified it to its absolute simple thing, which is easy to read. So TensorFlow datasets, the library, because we're doing TensorFlow certification, directly dot load, name of the data set we want, kind of split we want, and shuffle and things or not. So this is TensorFlow datasets catalog. You can find it here. So many data sets we have, three biology, audio, this thing. So advantage of ready-made data sets. And another place for this is Hugging Face data sets. I prefer this because this is where most of the open source community of data science lives. So recommended place is here. But for certification, what can you do, right? So simplify the code, reduce this unnecessary glue code which needs to be written again and again and again. So write scripts for them, standardize them, and just get it done once, when in a good to write, easy to read and understand format. Fix the library. I would recommend PyTorch. TensorFlow, you can maintain it separately. So what I have decided is actually this, because eventually both will I will need both. So what I want is this, libraries, and in this let's make TensorFlow. So I want TensorFlow and PyTorch to be their code snippets maintained separately. So whenever I want, I will just pick up the code from here, so that it is easy to read, and just whenever you want to use it, I can just go here, call, and whatever thing I want, let's say data set from Hugging Face. I have created this snippet once, so I have just copied it and copy paste it, and done. So that's why simplify the code and then save it into your code manager, so that you can just get it, and you have these pieces which are ready. You just combine them and put together, and your experiment is ready. Because the annoying thing is this data set downloading, processing, all of these things are extremely annoying. It's time consuming. Just 5 to 10 minutes of break, which it's like, you are not allowed to pee in one shot. It's just you have to take pause, then pee a bit, pause, pee a bit. It's kind of like that, these slow things. So simplify the code, make it such that just in one line everything happens, and get the end-to-end experiment working first. Very, 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 very important. This is so time consuming, even taking one example and learning from it, which involves forward pass, then back propagation, gradient calculation, updating it. It's time consuming. And when our data set is big, the small things add up a lot. So training time is eventually quite a lot. So get it working first, and get it working first on small data, so that you're not wasting time. Our aim is get to end quickly. We are not concerned about accuracy. Just take the data set, just read 10 examples, just read one batch, and train the neural network end to end on it. Get accuracy. Of course you're going to get high accuracy, because you're just taken one batch, but aim is get the end to end pipeline working first, and then you kind of like change the code for so that it is easy to read. So I did all of that here. Okay, I've changed the function, I've changed the order, so that even spaces are at equal distance, so it is easy to read and understand. Simplified this whole thing, and so that when we write the model, it is easy to understand. So, and another thing people do is like they don't write it in a way which is easy to understand. So I have also changed how the model is written. So if you check in this code, it's like a functional model they use. So Keras actually has three ways you can write models. So you can check Keras model definition, model class, sequential, functional, and then there is this what I've done. Where the hell is that documentation? Wow. You never find things when you need them. There are three ways to instantiate functional subclassing model. Yeah, this one. Functional, sequential, and yeah, this sequential like this. This is very easy to write. That's why many people choose it, but it's not easy to read and debug. Then there is people prefer this. It is easy to read and understand, but again, not easy to debug. So I recommend this third approach. And you can make the code a bit easier to understand. So check how I've made the code. So custom model class, it is extending a Keras model. Okay, so initialization we are doing. First, we initialize the base model. Transfer learning we are doing. What we do is we take a existing trained model which is trained on a data set which is quite good representation of real life. So for example, this is ImageNet data set. This is a very good tool where you can see some of those data sets. So you see there are around 1 million images here, which are real life images. You see dog, I don't know what this is. This is lizard. So this is our real life data. Okay. And we have trained a model on it, and it's like a ready made available for us. So whatever the use case, if this model we can reuse for our use case, that's what we do in transfer learning. So I've taken it, I've set it as non-trainable, and then check. I'm defining input layer, simple input layer, then embedding layer, which is, I am converting the previous layer's output to a 2D vector, a average pooling. So every data is converted into this thing. Then we have a fully connected layer. It's FC1. I should have written fully connected because every neuron is connected to every other neuron. Should write in a easy to read way, fully connected layer. But then this order is going to change. This bloody hell. And then activation layer. So tf.keras.layers, everything you can find here. Easy to read, easy to understand. And then I have used sequential. tf.model.sequential. Here I have given this input layer and the order in which, so input, I just take input which is passed to the base model, which is a ready-made model, and then passing it to embedding, then fully connected layer, and then we have activation. So here, because of this, if I want to debug, here I could actually write interesting code. So what I could do is this self.complete model dot layers. So list of layers is equal to this, and for layer in list of layers, uh, layers input. So here this is the list of layers, all the layers of this model. And if I want to debug what is the output of this, output of this, output of anything internal or something else, I can easily write the code here. I'm using sequential as is. I'm using it, but inside this way. I prefer this way. I'm sure this will not be easy. Everyone has their own hacky way of doing things, but I think there are many reasons this way is superior. And even in PyTorch, people do it like this. So this kind of structure is used in there also. That they have this PyTorch module, and then its forward passes like this, and inside this they use sequential model because easy to write, but they make it by using this object oriented approach because it's easy to debug. So best of both worlds. So I did that, simplify the code, reduce the glue code, end-to-end experiment working, and this thing, and use weights and biases for experiment tracking because TensorFlow, Tensor board, it's kind of like useful but local, and weights and biases is just one line thing. Okay, so one line thing, this gets done here. So we have this, we do this model like this, define it, and this is not needed. So let me delete and we train it. Oops, wow. Of course, it's not good. So I've trained the model here. Maybe something I've changed. Should not have changed things too. Anyway, let me start executing from beginning. Okay, this, then model init, and then train. Yes, now it is working fine. So after doing this, reading the data set through these tools, then, and some much easier to read and write code, makes it possible to get end-to-end pipeline, introduction to this end-to-end pipeline. And as an application to this knowledge, I'm going to apply it to on this competition. This is a 7-year-old problem. When it was there, it was just 2 GB of data. It's quite a good amount of data. We are simply going to do fish type classification. At that point, I think 10, $20,000, very useful, socially useful problem. So now we can solve much more complicated problems, but we got to start somewhere. So this is the knowledge. This is how I have created notebook. You can find it here in this. Okay. And next thing to, after I do this end-to-end learning multiple times, I've gotten the whole code, very mastered. Then I will attempt this competition and attempt to get on the leaderboard as a way of practicing my knowledge of computer vision with TensorFlow.